In this video, I am going to demonstrate the chain rule doing several examples. Just so we have it up here, I will write down the chain rule. Imagine we have a function f of x, which we can write as O of I of x. I choose O and I. I is our inner function, O is our outer function, and we'll do a bunch of examples here, so we'll see what that means. So the derivative of this function is the derivative of the outer function applied to the inner function times the derivative of the inner function. Okay, so taking derivatives for the chain rule is all about choosing the inner and outer functions. And sometimes that's pretty straightforward. These ones are pretty clear, but sometimes it's a little harder to think about. And you do have choice of outer and inner functions. And what you want to think about are functions that you know how to take the derivative of. Okay, so this first example, we're going to choose our inner function to be x squared plus 2 and our outer function to be e to the x. Now we'll just write down the derivatives. So the derivative of the inner function is 2x, and the derivative of the outer function is simply e to the x. And now we can write down our derivative by using our formula. So it's the derivative of the outer function, e, applied to the inner function, so e to the x squared plus 2, times the derivative of the inner function, 2x. So that's 2x e to the x squared plus 2. Okay, this next function, again, inner and outer functions, we have to choose them. Again, pretty clear what we should choose here. The inner function is x squared plus 2x plus 2. The outer function is natural log of x. Write down our derivatives. Derivative of the inner function is 2x plus 2. The derivative of the outer function is 1 over x. And now we can write down our derivative is the derivative of the outer function applied to the inner function. So that's going to be 1 over x squared plus 2x plus 2 times the derivative of the inner function, 2x plus 2. So that's simply 2x plus 2 divided by x squared plus 2x plus 2. Okay, this last function, it's a little harder to see what inner and outer functions we should choose, but I'm going to choose as my inner function 2t. And the reason I'm doing that is because I know this is 1.025 to the power 2t, and I know if I had 1.025 to the power t, I know how to take that derivative. So inner function, so t this time is going to be 2t. The outer function is going to be 100 times 1.025 to the power t. Derivative of the inner function, t, is 2. The derivative of the outer function is 100 times 1.025 to the power t times the natural log of 1.025. So we now take our derivative. H prime of t is the derivative of the outer function applied to the inner function. So it's 100 times the natural log of 1.025 times 1.025 to the power 2t, plugging in the inner function, times 2. So that's equal to 200 natural log of 1.025 times 1.025 to the power 2t. And that's it. The key to using the chain rule is, well, one, remembering it, but two, choosing our inner and outer functions wisely. And our goal is to find an inner function and an outer function for which we know how to take the derivative.